Atoms and molecules of matter are always in motion. Constant, random motion. Because they are moving, they are the source of what is called thermal energy. The faster the atoms and molecules are moving, the more thermal energy they will possess. So, is there a way we can quantify the thermal energy of a piece of matter? Yes, the way to do it is by measuring the temperature of the substance. Temperature is the measure of the thermal energy of a substance, which is another way of saying that temperature is the measure of the kinetic energy of the atoms and molecules of a substance. The hotter we perceive an object to be, the greater the motion of its particles. And that means the greater the thermal energy. And how do we perceive thermal energy? We perceive it as heat. Heat is the transfer or exchange of the thermal energy that is caused because of temperature difference. There are three common units of temperature. They are the Fahrenheit, the Celsius, and the Kelvin. We need to know how to convert from one temperature unit to another, because in the United States, we mostly communicate in Fahrenheit, but the rest of the world mostly use Celsius. And the SI unit for temperature is the Kelvin. So we must be very good at converting from one unit to another, because if you are an American and you travel to, for example, Canada, they do not use Fahrenheit. In Canada, you would have to speak their language. So how do we convert from one temperature unit to another? To convert from one temperature unit to another, all we need to know are the boiling points of water and the freezing points of water. What do I mean? On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit. Under the Celsius scale, 0 degrees Celsius is the freezing point of water. If we want to convert from Fahrenheit to Celsius, we also need to know the boiling point of water under the Fahrenheit scale, which is 212 degrees Fahrenheit. And we also need to know the boiling point of water under the Celsius scale, which is 100 degrees Celsius. So how do we make use of these four different points to know how to go from Fahrenheit to Celsius or vice versa? Very simple. If you look at the Fahrenheit scale, the difference between the freezing point and the boiling point is 180 degrees Fahrenheit. The corresponding difference between the freezing point of water on the Celsius scale and the boiling point of water on the Celsius scale is 100 degrees Celsius. So I'm equating them because they describe exactly the same thing, from freezing to boiling. So 180 degrees Fahrenheit should be equal to 100 degrees Celsius. If you divide both sides of this equation by 100, you get 1.8 degrees Fahrenheit is equal to 1 degree Celsius. And this is all we need to convert from one to the other. Let us take a look at a very simple example. Convert 98.6 degrees Fahrenheit, which is the normal human body temperature, to degrees Celsius. One thing to immediately realize when you are going from Fahrenheit to Celsius is that the Fahrenheit scale is larger than the Celsius scale. So, whatever value we are going to get for degrees Celsius should be a smaller value than what we have for the degrees Fahrenheit. And the way to do that is to simply subtract 32 from 98.6 degrees Fahrenheit. And if you're thinking, why do we need to subtract 32? Well, if you remember from this equation, we are setting the freezing to boiling equal. But the Fahrenheit begins from 32, while Celsius begins from 0. That is not fair. Subtracting 32 from the Fahrenheit is a way to place them on equal footing. After subtracting the 32 from the 98.6 degrees Fahrenheit, you then divide by 1.8. That should give 37 degrees Celsius. Let us also look at how to convert from Celsius to Fahrenheit. Let us take a look at this. Convert 25 degrees Celsius to degrees Fahrenheit. If we want to do that, again, we need to know what we're trying to do. We're going from Celsius to Fahrenheit. We expect to get something that is bigger in value. And how big? Well, the very first thing to do is to multiply the 25 degrees Celsius by 1.8 and then add 32. This is exactly the opposite of what we did for conversion from degrees Fahrenheit to degrees Celsius. And this should give us 77 degrees Fahrenheit. To convert to the Kelvin scale, all we need to do is first convert the temperature to degrees Celsius and then add 273.15 to the degrees Celsius temperature. How did we get this? Where does it come from? We will learn more about the 273.15 number when we get to the chapter on gases. The second formula here is the formula we used to convert from Fahrenheit to Celsius. Remember, we subtracted 32 from the degrees Fahrenheit and we divided by 1.8. Let us take a look at a question to practice what we have learned so far about temperature conversion. Take a look at this question. We want to convert 67 degrees Fahrenheit to Kelvin and degrees Celsius. The very first thing I would do if I were you is to convert the 67 degrees Fahrenheit to Celsius. And to do that, as you know, we're going from Fahrenheit to Celsius, we should expect something smaller in value. So, how do we get something smaller in value? We first subtract 32 from the Fahrenheit measurement, and then we divide by 1.8. My calculator gives me 19.44444 and so on. This will now be in degrees Celsius, which is the same thing as 19.4 degrees Celsius. It is always a good idea to round temperatures to 1 decimal place. Now we can convert the Celsius scale to the Kelvin scale, which means we are going to add 19.44444 degrees Celsius because we do not use approximated value in subsequent calculations. We add 273.15 to this. And if you do that, you should get 292.59444 Kelvin, which again rounded to 1 decimal place would be 292.6 Kelvin.